want to follow along with check back data. I'm a little groggy. I just got back from Tokyo. This was a conference in Tokyo this weekend. The time zones are all messed up for me. But let's get right into it. Usually I talk a little bit about front-end JavaScript issues, a little bit about ops and things, but you guys are a bit more advanced audience than I can. And I couldn't possibly out ops the week you're talking like that. That was pretty awesome. So assuming you haven't done any idiotic things at the ops level, assuming you haven't done any idiotic things at the front-end JavaScript level, how do you speed up your PHP backend code? And does it really matter? Isn't this stuff all about scaling? Why does performance actually matter? It's kind of a far out to scaling. Scaling is all about architecture and running things in parallel concurrency. But performance really does matter because even if you scale to 100 servers or thousands of servers, if one individual server is slow, you're still slow. Right? In the end, one user is going to be hitting one server that's going to be sending one answer back to them. If there is a 600 millisecond latency to get that one answer to that one user on a lightly loaded system, then your system is still slow. No matter how much you scale it, it's slow. So single server performance really does matter. You want to get that latency down as low as you can on a single server basis. Of course, you have to make sure the stuff scales as well, so that when you do get pounded with requests, the latency doesn't suffer too much. But you have to start at the base performance level. Single server, single request latency has to be as low as you can possibly get it. And then try to maintain that level of performance through scalability up as you scale up in those. So, there are a few of the reasons to go fast. On the slide here, Google PageRank now takes your performance into account. Slower latency sites will get lower index than higher latency sites. Low latency sites. It's just not proven to be slow. So, in order to figure out if you're slow or not, step one is to measure, right? Use some kind of benchmarking tool, something that will slam your server as hard as it can and see how fast things go. I'm using a little tool called Siege. There are lots of them out there, like HackerBench and others. That will slam the server at whatever concurrency level you configure it to do and measure how fast the server is responding. So in this case, I installed a copy of the new version of Drupal. I wanted some big complex code base to have a look at. So this is Drupal 7 from our recent CDS checkout. I'm running it under the new PHP FPM, the fast process manager, fast write process manager that's over here to PHP 5.3 now. Nginx 0764. And no ABC, no output cache or anything for this baseline test. And the numbers that are interesting here are the transaction rate, right? About 8.5 requests per second, and latency of about 570 milliseconds, 0.57 seconds there. This is against the VM running on my laptop, so obviously this is not a production serving environment, but it's good enough to see relative performance as we choose things. So the very first thing you do, if you at all care about PHP performance, is to install an optical cache. If you haven't installed an optical cache on your PHP setup, great news, right? You get an instant 3x, 4x speed up just by installing that. And I've just made your conflict worth going to. If you didn't know that before, I'm telling you to install an optical cache. Perfect. But you guys probably, if you're running PHP, probably running optical caches already. With an optical cache, Drupal 7 went from 8 to 31 requests per second, from 570 milliseconds latency down to 160 milliseconds latency. So you can see the drastic performance improvement. And obviously what the optical cache does is it sits in between the compile stage and the execute stage. It compiles the script down to a set of opcodes. It stores those opcodes in shared memory. And then on the second request to the same script, we point the executor directly at shared memory. So we don't have to recompile the script. We don't even have to get the disk. necessarily, other than the stat, just to check if the script on disk has been updated. And then we point directly to shared memory and execute out of shared memory. There are two things we have to copy down into the executor space, because there are things that will be written to just for that request that we don't want to write to the shared space. And that's the complex part of the output cache, is getting that balance correct and making sure we're not overwriting things in shared memory that are executed in other threads. So, obviously you want to make sure you're CPU bound. If you're trying to optimize the system like this, if you're waiting on some other thing in the back end of your I/O bound, you need a faster disk system. Or you need to look at the server you're waiting on and dig down and find the CPU bound blocks that you're waiting on. But assuming we're CPU bound, we can continue. So a question I get a lot is, so which web server is fastest? It really doesn't matter. If you're running a big complex code base, the web server piece of it does not really affect performance much. There are two numbers being shown here. So there's 3 web servers. Red is Nginx, green is slightly, blue is Apache. The solid lines is the number of requests per second we sort of calculate. The dotted lines to the right-hand scale is the latency as I increase concurrency. And there really is linear. As I increase concurrency, the latency goes up. It doesn't look linear at the end of it. That's because I got the latency drop by 10s the last 2 measurements. So it's pretty much the same within margin of error on my measurement, at least up to concurrency of 15. Above 15, Apache started getting a little wonky, but it came back up around safety. So it really isn't that far off in terms of the different web servers there. It comes down to what's easier to manage, what you feel more comfortable with, what has the richest set of extensions and rules and things like mod rewrite for Apache, something a lot of people rely on. Personally, I'm using Nginx these days for little startup as I'm in now. Nginx and PHP can do well server. Alright, so whenever we start talking about performance in PHP, the thing that usually kills you, our system calls to a slow disk subsystem. Of course, if your disk subsystem is fast, like including solid-state drives, and then maybe you can still skip this slide completely. But most of us are not using solid-state drives yet on production servers. And if you're not using solid-state, you're going to have slow disks. And every time you need to ask the disk a question, it's going to move something physically, and that's going to slow you down. So when I was looking through Drupal 7, I saw all these opens on a single request. Right, the front page of Drupal 7, it went and needed to look at all these files. And that's a lot of things to have to pull in just for a single request. And there's a nice little extension called include, I-N-C-L-U-E, spelled out on purpose, that gives you this picture of a PHP request in terms of what's including what. You can find it on the technical PHP.net/include. And it'll draw this nice picture. And for Drupal 7, you see we started index.php, which loads does it require once on Bootstrap. I have this personal vendetta against require once. Everyone seems to use it everywhere. So what require once does, if you haven't seen it before, is it basically makes sure that this file is not required multiple times. So it basically has multiple inclusion detection in here. We keep a list internally of files that have been included. So we do a require once of A. The first time it checks the list, does a hash lookup on the list to see has A been included? No, okay, that's included. Second time you do require once A, it checks the list. Oh, we've already included that, ignore. Right? I think you should be able to write code where you know whether or not you're requiring the same file twice. I don't think that should be a runtime check every single time. But it's there, and because it's there, people use it all the time, even going from index to bootstrap. I'm pretty damn sure that in that one index file, you're only going to build the bootstrap once, right? This is not required. Answering the bootstrap, every single include in here is an include once. The settings, cache, database, block, module, all of them, all include onces. So there's an extra hash lookup. Every one of these to go and check, hey, have we included this file before? And And there's a bit of inefficiency built down in PHP as well, where we assume that the next operation is to open up this file and actually start executing stuff in this file. So we do an open call early on, which will get called when you do an require once. We've worked around that a little bit in PHP 5.3 and APC to try to optimize this, but the easiest way to optimize it is just to not do that. Don't write include spaghetti like this, where you don't know what's including what and when. And just the fact that you have to include this many files. The dotted lines, here's where they include extension. The text that you can include in the same file twice. So the dotted line is the second time you're going to include once in the same file. You really shouldn't be writing code that does this in production. Run this include tool on your development code and find the spots where you're actually doing a double include on something and then get rid of it, because it's complete overhead, right? There's no point in doing that second require once. There's no benefit. But PHP is a scripting language, right? It just sort of runs through and executes every opcode, and it's going to do each step along the way. There's no optimization. There's nothing that optimizes this stuff out. You're getting hit once every 3 milliseconds. Every 3 milliseconds you're doing these redundant operations. It makes no sense. You don't do that. So here's Drupal 7's Bootstrap code. This bootstrap full function to solve. And inside there, they have more protection against double inclusion or whatever. I'm not sure why you're calling bootstrap twice. So you see at the top there, they have a little thing that says how we did call before Drupal static function. How we did call before return. Don't do anything. And then we do all the requirements inside. So they're being really, really paranoid about being double bootstrapped. I don't understand that. Just don't even check. If people do call bootstrap, twice, fine. You'll get function redefinition errors and the thing will just fail. Who cares? Let it fail. Right? If someone's hacking around trying to do something weird, let it fail. Alright. And then they also go a little nuts with their database autoloader. Basically, every single Drupal hit needs the database, because every page is a node in the database, and everything needs to talk to the database. There is no page in the Drupal site that does not talk to the database. But they're auto-loading even the base database class, which is this database.h. They're auto-loading that on every single request. So that didn't make much sense to me either. At the very least, something like this includes every single request. Don't follow auto-loading it. Just include it at the very top, like maybe a bootstrap or whatever. Include it early on, and then just assume that everybody assumes from then on, yes, the database class is available and ready to call. Right. Then they also go hunting around for their settings. This is something most apps have problems with. How do we handle configuration settings? Right? And when I did an S-trace on a request to a Drupal 7 page, you see that it took 4 tries before it found it on the 4th try, found the settings for this app. And this was just the default install. They didn't do anything strange. So by default, they miss the location where the default configuration is on the default install, which makes it absolutely no sense. Why is the default not the first check? I guess so we can maybe personalize it more or something, but whatever. Put a switch in the default places and then find those other places. So I didn't like that I went hunting around missing 3 times. So the bootstrap code looked like this. I just got rid of most of it. And I got rid of the comp path and I just hard coded in where to leave the configuration setting from. So now it didn't help a whole lot. So I made those changes, got rid of require onces. We were at 31.15 and 160 milliseconds. And after I got rid of all the require onces, I fixed the bootstrap stuff, I fixed the DB all the way in. Added about 1.5 requests per second to it and shaved off 10 milliseconds of latency. But it also only took about 30 minutes to do that. Right? If I were to dig down deeper in this code and 10, 11, 30 minutes. I'm sure I could shave off a few requests per second here or there. Just by looking for stupid things. And a lot of it we can pick out of the S-strips. Take a typical request to the most trafficked page, look at all the system calls, and see if you can explain why the system call is being done. If you're seeing a bunch of events, you know you have a problem, right? You never want to, on a production system, on the most trafficked page, you don't want to go to the file system and miss. It shouldn't happen. So one thing Drupal is doing, I did a talk in Hungary a couple of years ago where I said, look guys, you're starting to become much more than just a PHP script, right? You're becoming a platform. You're becoming this platform that people build on top of. You should start acting like one. And one thing I suggested was take some of your most often called functions and take sort of the core of Drupal, write it in C, write it as a PHP extension. So they started doing it. They have this Drupal PHP extension, but they've only implemented 2 functions so far. There's one called Drupal static, and there's another one called check plain. Check plain is good. So you can see this called a lot. Check plain is called 118 times on a single request, and Drupal static is called 198 times on a single request. These numbers are out of K cache line. Right, so this is running Valgrind and then running the whole grind, the profile inside Valgrind, and just running the entire Nginx, or the entire PHP in this case, inside that. And it's pretty cool. If you haven't seen it before. So you get an output like this. I was running different things. So you can go through and you can have a look at the C level. So you have Apache here, you can see all the calls and things. But the one I actually want to show you is going through and doing the same thing via Xdebug. Xdebug can spit out the same format as Valgrind does. And here you can go through and you can look at the various Drupal calls at the PHP level and see how much time is spent in each one. And you can sort by a number of times in each calls. There's 198 calls for Drupal static. And then we have the check point somewhere in here as well. So that's how I got those numbers. But you install it, and you only get maybe 1% speed up installing on the standard default install before I have any optimizations. And the reason they don't speed up that much is because, first of all, those functions are pretty fast. They don't do much to begin with. And second of all, in their PHP extension, they added an rinit and an rshutdown. Rinit means request init, rshutdown is request shutdown. That means on every single request, it's going to call some initialization code. It's also going to call some shutdown code. We try really, really hard to avoid any rinits and rshutdowns. In every regular PHP extension, you should try to avoid it. Because this is called, even if you're not using anything in that extension, it's still going to call the rinit and the rshutdown hook for that extension as soon as you enable the extension, even if you don't call anything that the extension gives you. And they have a lot of playing around with hashes here, with destroying hash tables and things. So there is some extra overhead required for it. I mean, it's still faster than doing it in PHP, but it isn't as fast as they need to be. And they didn't really implement the guts of Drupal in C. It just took 2 little functions that did very little and put them in C for now. But it's a step in the right direction. And if you really care about performance, you should sit down and profile and see, is there anything here? Is there some piece of my profile graph that I can obviously translate to C? There's my average. Oh, magical. I would do that in my pocket. So, that's the Drupal extension. And in itself, it's not that much different to you guys. So what Drupal is an extension, but rewrites in C. That was kind of the original idea for PHP. When I started this stuff back in '94, I thought it was insane to write anything in a templating language, right? And when you write the templates in the templating language, you write all the heavy lifting in C. And that's what I did back then. But the web grew so fast and it was written by so many people who did not know how to write a C program that they started writing very, very complicated logic in the templating language itself. And I'm sitting there looking at you like, what are you guys doing? This is nuts. But because so many people were writing stuff in the templating language, we were kind of forced to improve the templating language over time. Say, okay, well, you guys are doing completely crazy things here. I remember when the first person asked for recursion. Recursion in a template? What? Why would you ever need recursion in a template? It makes no sense. Then he started explaining it, and he was like, fine, I'll add recursion. And I did that back when I was PHP 2. I didn't have any static variables. So there's no way to get out of it. He didn't ask for that. He only asked for recursion. All right, anyway. So a new thing that's come out of Facebook. So Facebook is huge, obviously. Hundreds of thousands of servers, millions of lines of PHP. Some of it pretty bad. A lot of it's gotten a lot better lately. But I talked to them quite a bit, and they were asking, so how did you make PHP work at Yahoo scale? And I said, C++, Dan. That's how we do it. We wrote 500 plus extensions, mostly in C++. So when people ask, well, how can PHP handle Yahoo loads? I said, well, because PHP is a templating language of Yahoo, heavy lifting is done in C++. It is super, super fast. C++ is damn fast, right? They said, oh, we can't do that. We don't have enough developers that know C++. We have to make our PHP faster. So they went with this crazy approach where they said, well, let's just turn our PHP into C++. Magically, with a button, right? Then it'll run fast. And when I first saw that, I was like, man, you guys are nuts. But they actually did it. They wrote this static analyzer that can really pick up our PHP and turn it into C++. For the most part, there are a few things that don't work. And in this case, Drupal 7 doesn't actually work under HIP. So there are lots of code bases. If you're going to try HIP on your code base, set aside a week to get it to work, because it's not easy. In this case, I tried pretty hard to get Drupal 7 to work under it, but there are some issues with the session stuff that can be worked around. The bigger problem is PDO. Hip-hop has to rewrite every extension, essentially, from the PHP version to a hip-hop version of the extension, and they are not always compatible. And the hip-hop PDO extension can't do the same things that PHP's PDO extension can do, and that's why Drupal 7 is just not going to work with hip-hop from now on. One shortcut way of getting a list of files, because you have to give hip-hop list of files that are part of your project. And one way of doing it is just listing everything. It takes forever to compile all these files from PHP into C++. So you want to just take the minimal set that you're actually using. One way of doing that is just to grab out your ABC cache. You can do a cache info, and you get the cache list of all the files that are actually in the cache. So if you click around your site, so use every feature of your site, then dump the cache list, then you have all the files that are actually needed for the site. And then you feed that to the hip-hop compiler. The hip-hop compiler gives a file list, input list file, all or whatever else. Force equals 1. But basically it's just ignore all the names, try it anyway. Because you're going to get tons of ones mostly. And then you wait a long time. In my case, to compile Drupal 7 took 34 minutes. But what you get out of it is kind of cool. You get a standalone library called program. And program contains a threaded web server, plus all your PHP code compiled or converted to C++, and then compiled into a native library that's linked into this program. Right? So you throw away your Nginx, your Apache, your Lite, you throw away the ABC, you throw away PHP SDN, everything is gone. You now just have the standalone library that does everything on its own. Which is a little bit scary as well, because all your various web server rules and things, you don't have it anymore. server and then put something on top of it to proxy it probably. But when I run it, it doesn't work because of the PDO issue. So if I go back to Drupal 6.19, I actually did this last night because I didn't want to show you something that didn't work. So you don't try the most recent Drupal, but the current stable version, which is 6.19, that actually runs a little faster than the new one. They keep saying Drupal 7 is not faster. I'm not quite seeing that yet. Maybe they have plans to get there. But Drupal 6 is running at 55 requests per second, 90 milliseconds latency with PHP, FPM, and APC. Under hip-hop, unfortunately, it runs a little slower. So it was quite a bit of work to get it working. And it runs about 1 request per second slower and about the same latency. Theoretically, it should be a little bit better at higher concurrencies, although PHP FPM on the Nginx is pretty damn good at the high concurrency as well. So in this particular case, hip-hop didn't do much for it. I haven't done it good to see what went wrong. Because in theory, what I saw with previous WordPress hack that I did was I got about 10-15% speed up going to hip-hop on a lightly loaded machine, and as you load it, 25-30% better performance on the really, really high loads. But with Drupal, I haven't seen that. One interesting thing is just one slide out of my WordPress presentation is that hip-hop, because it has to convert PHP into C++, it really needs to do a lot of static analysis on PHP to try to figure out what is the model trying to do. And in an early version of WordPress, the CDS version of WordPress, it found a bunch of silly little mistakes. So stuff that the PHP compiler doesn't see, doesn't care about. Like in this case, someone was casting on the left side of an equal sign. They're saying int seconds equals array top. That doesn't make any sense, right? So it'll convert seconds to an int, and then it'll overwrite it with whatever comes out of the array top, right? We did that in a bunch of places. Hip-hop is net. Good at handling dynamic file names and requires and things. So if you're trying to convert things over to hip-hop, you might have to change some of that. But it'll tell you as you compile if you can't figure it out. It sometimes figures it out, but I'm not quite sure exactly when it can. It may be dynamic includes inside of functions. I'm not sure. It also caught this one, the PHP's compiler doesn't catch. If you look at it carefully, there's an equals missing on the first line. So they did cat p or something. And then they did cat p dot capabilities. And didn't do anything with it. So they concatenated 2 strings. That is a valid expression as far as PHP is concerned, but they didn't assign concatenated those concatenated strings or anything. They obviously meant objects, I think they meant objects. And a couple of other little changes. This was fun too, that hip-hop caught that PHP didn't catch. So there's a function there called default password negative user that takes a user ID as the first parameter. But then the first thing the function does inside is say global user ID. Right? So in global, the global keyword in PHP means go and fetch this variable from the global namespace, right? But you pass in a variable called user ID. And the first thing you do is you override it to the global version. So the passed in one is going to be ignored completely. Now in this case, they were passing in the global. So it was the same value. It didn't break anything. But it is a weird thing to do. And hip-hop static analysis was smart enough to say, wait a second, that's odd. Why are you doing that? So if nothing else, I would suggest running hip-hop on your code just to see what sort of weird static analysis things it can catch. And go through those lists of warnings and see if you get something stupid like this. Because this could be a real bug, obviously, right? All right. So, we didn't see a lot of speed up from running hip-hop on WordPress or Drupal. WordPress was 10-15% faster. Drupal was about the same speed. how do you get that performance out of your PHP stuff? If hip-hop isn't going to solve all your problems, getting rid of a few required classes isn't going to solve all your problems. You saw I went like a question and a half more performance out of that and try that. How do we get massive speedups, assuming you already have optical cache? A couple years ago, I wrote a little application called Twitter. Basically treats Twitter as a database. You put in various searchers, and then you can assign them to various people in the organization to various things. So it does about 5 or 6 MySQL queries on the page to build this little thing. And you have flag treats and things to look at, interesting stuff. So it does, in terms of the amount of things it has to get from the database, it's about on the same order as the Drupal front page or the WordPress front page. But it does a lot less manipulation of that data internally. The rendering inside Twitter is minimal. If we go back and look at our page hash map, let's go more the picture. Talks through 1024. But if we go through and have a look at what's actually happening in here. So we have the bootstrap 13%. Bootstrap page cache at 4%. Drupal delivered page. Did I turn myself off again? Drupal delivered page at 58.84%. So obviously, we're spending most of our time delivering the page. Right? The Drupal delivered HTML page 58 still, the rendered page 58. Now that gets split up into block page build 21%. And the other 30% are down here somewhere, 34%. And we keep going, Drupal render. Right? So we're spending a lot of time rendering the page and taking what we're getting to the database, applying templates to it, and spitting out the final result. And that's about half our time spent doing that. This is where, if they're going to write some kind of Drupal C extension, they should probably focus on. Maybe write some kind of rendering engine in C or C++ that can do this stuff a little faster. Now, if you didn't spend all your time thinking around the data, there's also a bunch of unserializing some of the text. There's like 20% unserializing data. They're serializing everything in the database, and they're unserializing and putting it into templates and doing all this stuff. If they had a more direct path from the database to the page, they would go a lot faster. How much faster? Well, this is basically what this application does. Right? It takes the database, spits it out, uses a JavaScript client library that does most of its client side, spits out the page, and we're getting 240 requests per second on that front page at 20 milliseconds latency. Doing about the same amount of backend work as Drupal WordPress. That's without latency. With latency, it's 378 requests per second at 10 milliseconds latency on the same hardware. So performance is not about little tricks you do. I saw someone that labeled my talk the PHP performance checklist. There's no checklist.
Except ABC.
Right, okay. There's one item in the checklist, ABC. You're right. It's a short list. But once you have an optical cache in there, hip-hop isn't going to solve your problems for you. Little tiny tricks here and there that you might read about in various blogs isn't going to solve the problem for you. What's going to solve the problem for you is that you think about performance as you're writing your code. You profile it, and you associate cost with everything you do. If you're building a rendering, it has to pull templates from here. Maybe it uses XPath and an XML file and doing all this kind of stuff. Great, I'm sure it's very, very nice, but what does it cost? And every time you make one of these decisions to use some kind of indirect path to get the data out, profile it, measure it, know the cost. If you're okay with the cost, great. I have no problems with it. I have a problem with people doing stuff without knowing the cost. And then claiming to me later that PHP is slow. Like, well, no, what you did with PHP is pretty slow. I can write really, really, really fast PHP code. And you can also write really slow PHP code. So if I look at my Twitter thing, these are all the system calls it takes to serve up the page. It seems like a lot, but this is everything, right? Not just the system, not just this touching things, it's everything. And one thing you notice in there, I can't even find it now. that took like 6 extra system calls because I didn't have a fade icon. You're better off just sticking a fade icon on this side, just having that hit in one system call. And mostly it was because I had a 4.4 error handle. You can see the stats leading up to this fade icon. And I can't find it. And because it couldn't find it, then it ends up calling my 404 handler, which I have to solve. You have to solve half the things that go wrong because then you get this request for a file that doesn't exist. Goes looking for it, can't find it, then says, okay, you can solve the 404 handler, and it's called that. The 404 handler gets confused because they didn't think it was going to get a request for fade icon. So that was one little fix that I did to speed things up a little bit. And this is the full profile of this thing. There aren't that many nodes in the profile. So we have our main panel. Most of the work is in this clickable. So I'm taking the tweets and finding clickable links, turning things, putting an AH wrapper around the URL, putting links back to Twitter, the ampersand things, and just doing a big Lego version now. And the hierarchy. Remember the big hierarchy we saw for Drupal that was like 7 layers deep, we include ones with pylons everywhere? I don't think I've ever written PHP code that had more than 2 layers like that. Script includes, script includes, script includes. And I don't do a require once in database dubbing because I just assume if you have other things, both truth messaging, well, truth message requires the database. If I didn't include give you the link, I'd just get a fail error saying, sorry, database isn't there. Great. I catch that during development, right? I'm not going to deploy production code to figure errors in it. So if you include truth message.inc, there's a little documentation at the top that says this requires the database layer. Include that first. Much like C header files, right? It says, if you want this, you have to include that first. I don't think that C needs to do that at one time. If we try hip-hop in this tiny little application, it doesn't actually run faster, just like we saw with Drupal. In this case, I did a little bit of work on it. Went through and said, okay, why the hell is hip-hop slower? At the very least, it should be about the same speed. It shouldn't run slower. And I went through all the system calls, and I saw that it took 56 system calls for PHP and APC to serve up the front page. And in here, you see all the MySQL queries. You see one here, all the selects that we took. And so 112 system calls for hip-hop. So that's across all the threads, and there are threads that aren't doing very much. So I went through and said, okay, only really 2 threads are interesting. There's the web serving thread that answers 480, and then there's the PHP thread that does the actual PHP execution. So filtering out the other threads, there's only 75 system calls. And here we can go through and we can pick out the same MySQL queries. Each of these system calls are identical. So what I did was I went through and said, okay, let's take off all the identical system calls because we know those are not the issue since we're doing the same thing in both. So take out the identical MySQL calls, we're down to 48 system calls left in the hip-hop version of this request. And then you go through and say, what are we actually doing here? We're doing some equals. That's not going to get through taxes. It's too damn fast. That's why it exists. Stat, that stat is actually there as well. You can get rid of that. So there isn't really anything in here that would cause us to slow down very much. Except read and write calls, all similar in both cases. Then I figured, okay, well, maybe hip-hop really is written for higher scale stuff. Maybe if I load it with 25 concurrent clients against it, maybe it'll speed up. Sped up a little bit, but it's still nowhere near the 380 that was running, or 388 that was running. At 50, 329, we're still slower. And I tried it with 100, 150 as well. It never got above 330. So we haven't found it yet. Then I went through and said, okay, let's go through all the damn call graphs. Let's see what's happening in there. I had a picture of PHP, see the call graph of hip-hop, sort all the functions, and sort the costs of the functions, and I got down to this list. In PHP, SIF prerequisites. SIF stands for send internal functions, so the level profiling, that's what you will see. Anything that starts with ZIF is something that is called from user space PHP, but then invokes that function in the C version of that function. And it made sense, that's what I expected. 28% in my regular expression, that was that clickable thing, that clickable function. Pass the gate is an internal catchy thing that passes data around and actually delivers the data to the user, so it makes sense that that shows up in the profile. Print variable, okay. String to time, date, and request startup. So those are the 6 most expensive things in this little app that ran really fast, under 380 requests per second. In hip-hop, did the same thing in the top 5, applicable, which kind of matches, that's what does the record there, so it makes sense. Send raw is like pass the gate, that's what actually sends the data to the user, right? Then some row cards, trip nav, whatever. That time zone current in there, 20%. That's the one that stands out. Hey, we didn't have that in the PHP version. And the only reason for it is because in the PHP version, I have a PHP INI file that sets the current time zone. In the hip-hop version, it doesn't read my PHP INI file, so it doesn't set the current time zone. So at runtime, it has to magically figure out what the time zone is. So it has to ask the operating system, and getting the current time zone from the operating system is a notoriously slow operation. So all I needed to do in my application was put in the time zone at the top. So set my time zone in the computer, in the application itself, recompile with the hip-hop, so it's probably hip-hop now, re-benchmark it, and I got my speed back. So the specifics of this particular example are about the process by which you get there. When you do something you think should go faster and it goes slower, so by process of elimination and by knowing the costs and knowing what to look for and seeing things that look out of the ordinary or something you can't account for, like why is this here? Why are we spending 20% of our time here? Is there some way to not spend 20% of our time here? Like getting down to the current time zone. So we did speed up a little bit, right? From 388 to 408 on this particular small application with hip-hop. So in those cases, and I'm sure if I spent another couple of hours with Drupal 6 hip-hop, I would find through the same process what it was that made Drupal 6 a little bit slower under hip-hop than it is without, because I do expect it to be faster. So, performance is all about flexibility versus cost. All the big frameworks out there, Drupal, WordPress, all these things are very configurable. There's lots of things you can change on the fly. You can even switch out the backend database. And that also means that at runtime, it goes and checks, hey, are you using MySQL? Yes, okay, then we're going to load MySQL files, and we're going to load this ORM piece for MySQL, and off we go, we can have the MySQL query. Then 3 milliseconds later, hey, are we still using MySQL? Yes. Okay, let's go load all the MySQL stuff from here, let's load the ORM stuff from here. Now we can send the query. 3 milliseconds later, yes, we're still using MySQL then, stop asking, right? So that's what we're doing in runtime. You're not going to change the database every 3 milliseconds. Sorry, there's no way. You need to hard code that, okay? You need to rip out the guts of some of these runtime decisions. There are some things that are just not going to change. I also noticed in WordPress, for example, it keeps checking to see if you have configured your WordPress installation. If you haven't configured it yet, you go into this installation mode, which is very, very handy for new users that automatically put WordPress under your document group, point your browser at it, and kick it into the installer. Great, fine. But once you've done that once, and once you've been running WordPress for 6 years, you don't need that bad installer anymore. You don't need all that code that does this check on every single request. So it's another piece that you can rip up that you will see if you do some profiling on it, and you look at all the files that are included, the status and stuff. You see that why am I including all this stuff? I don't need it for the normal case. So it's all about knowing your costs and knowing your system well enough. You put a big graph on your wall that has all the moving pieces with a cost next to it. In your regression testing, you shouldn't just test for things breaking, like features breaking, site breaking. You should test for performance degradation as well. If you're suddenly 20% slower on your next release, your regression testing should catch that and say, hey, wait a second, problem. We're 20% slower than last release. What happened? Right? Very few regression testing systems I've seen test for performance at all. And they really should. Because to me, it's a huge bug if you suddenly go 20% slower. And that's something that should be taught. And know your tools. strace, I didn't speak specifically about it, but you saw the results, obviously. It looks at all the system calls. Call grind, profile that we can run inside file grind. Very, very handy to run at the C level of things. Xdebug can do profiling. Also does many other things, but in profiling mode, it spits out the same thing as call grind does. Look at the K-cache grind. XHProf is a tool out of Facebook that lets you attach profiling to every page, essentially. If you look through my slide deck, you'll see, I think the big talk I did a couple of months ago, I have an example of how you might configure your web servers automatically with a little XHProf button at the bottom of the page. So every page in your site, in debug mode and development mode, will have a little profile at the bottom. You can click and you can see the profile of everything that happened on that particular page. Always check your assumptions with profiling. You may think something is slow, you may think something is fast, check it. Or as Arthur said before, if you do change your backend, you suddenly put in solid state drives, all your assumptions that you had when you wrote your code are probably wrong at that point. So do your regression testing again on your new production hardware and change that hardware if the assumptions are wrong. And in the end, real performance is architecture. It's how you structure your code, much more so than which web server you're using, which language you're using. It doesn't matter anywhere near as much as architecture. The more injections you put in, the slower things are going to go. The further away from the hardware you get, the slower you're going to get. Virtual servers, as you mentioned earlier, the virtual servers are going to add some latency, unpredictable latency to your stack. All these pieces in there that you have to worry about when you're architecting. So, yeah. A couple of questions. Come on. You have a good chance now.
So I imagine you feel the same way about HTTP access then, like as opposed to configuring it in Apache?
Oh yeah. You shouldn't have ever, unless you have to, if you're an ISP, and you have to allow users to do configuration, you never ever have HTTP access anymore. And you'll see that in your S-trace. When you do an S-trace, you'll see stat. Because it has to stat every directory up to and including the directory that the document is being served out of. It's a complete performance killer. I didn't mention it because I thought that obviously it was it's never ever existed. Yes. The question is, do you think you could take hip-hop and have it turn a piece of PHP code into a PHP extension? No, because the internals of hip-hop are completely different from the Zen engine. They basically ripped out the Zen engine and they put in their own engine, right? Extensions are written against the engine. So their extensions, if you could do that, then they wouldn't have to convert every extension from the C that's written now to their version, right? They have to completely rewrite every extension for that reason. So you can turn it into a hip-hop extension, but that's what hip-hop does. So you're sort of in other words, not really. You can look at it. I mean, you can do it to get the C code, and you can look at it and you can use it as a guide. But all the Zen specific stuff, you're going to have to rewrite, and that's usually the piece that is hard. Others? Random questions, rights?
Just out of curiosity, I got to ask you about the competitors. PHP is really fast for a line drop, but if what other languages do you look at because of speed or efficiency or other attributes that PHP doesn't possess versus the process of getting better at?
C. When you talk about performance, you have to get to C or C++. At the scripting language level, they're all playing around in the same area. The C and C++ are playing up here. So no, there are no other scripting languages that try to even bother looking at performance. It doesn't matter at the scripting language level. The differences are so small. And you can write micro benchmarks that show that Python is faster when there's micro benchmark than this. For web applications, you're not going to iterate 7 million times over something anyway. And the fact that there is a 1% performance boost in Python on loops, for example, doesn't matter at all. When you actually profile your web page, that's nowhere near anything you've ever seen in profiling. So, at the scripting language level, not at the C level, definitely. Right? That's the only other language I look at. That's the only two choices for me. Is scripting language or choosing between scripting language for performance issues. You choose between scripting languages based on people you can get to help you out, so you don't write all the code yourself. You can't find anybody else to write Erlang with you. You might be wonderful at Erlang, but unless you plan on writing all the code yourself, you're kind of screwed. So that's the biggest reason for choosing one scripting language over another. You have 10 people, 10 Ruby buddies that want to join you, great, choose Ruby. If you don't, maybe you choose something that more people know.
Looking to the future, PHP 6, plan, timeline?
I killed PHP 6 a couple months ago. We got ahead of ourselves. Technically, I think it was probably not the wrong way to go, but what happened was we ended up having just 2 or 3 people that knew the PHP 6 code at all. We went looking around and we wanted to get to Unicode. That's the big thing for PHP 6, right? We looked around, we looked at the most established Unicode library out there is IBM's ICU, which is this beast of a library. It's massive. It's an order of magnitude more code than PHP. So we were adding a little bit of PHP to ICU, essentially, in this project. It was really complicated. ICU uses UTF-16 internally, so we figured, well, since we're doing lots of stuff with ICU, we should use UTF-16 internally, so we don't have to convert every time we call a function in ICU, which makes sense. But that also means that now everything is UTF-16. Every piece of data moving around inside PHP is now at least twice as big, which means memory is needing more memory, things are slower, iterating through strings and stuff are slower. But the biggest problem was that not enough people knew this new code. We sort of said that we're going to take a couple of people that's going to go forward with it, and everyone will follow. And everyone didn't follow. We said, screw this, we're going to stay with PHP 5. It's faster, it's more stable, we know the code, we're comfortable with it. I don't need machine code shit. And so we go, but we do need the code, damn it. It's like, well, I don't. And PHP has always been a very selfish project, in the sense that it's very pragmatic, and it's very much solving problems right in front of your nose. And Unicode is not right in front of everybody. Unless you're a big company that's trying to operate websites in multiple languages with one code base, most of us are operating in one country, in one language. I thought maybe in Asia we get more support, because they screw this, no, we know. We have our MB string, we know perfectly well how to launch stuff in Japanese. You're not getting any help from us. So we had sort of these couple of people that were out sort of as good of PHP trying to build this with all the more pragmatic folks going, screw you guys. We're not going to hold it. So it didn't work. So I killed it, and we're going to take smaller steps. I still think we're going to get there. We have all the code in the branch. So it's like 75, 80% done. Sitting in the branch, we're probably going to get there, but we're going to have to take smaller steps and bring developers along. Say, look guys, here's a small change from PHP 5.4. Okay, fine, whatever. The cows come performance improvements, all kinds of things that are beneficial to them. So things right in front of the nose will be effective. And by slowly moving them, maybe I can still get there. But there are still a few jumps in there that I haven't quite figured out how I'm going to do slowly. Right? How do we do a full switch to UTF-16 slowly? I don't know how to do that. What I really need is someone to write a UTF-8 Unicode library that do all the same things ICU can without forcing UTF-16. Or maybe it doesn't matter. Maybe computers have enough memory by now that who cares? I don't have a good plan yet for how to get to it while not pissing off people along the way. That's the hard part. Implementation isn't that hard. It's kind of clear what we should do for PHP 6, but if nobody comes along, it's useless.
have done completely differently or ripped out?
Biggest problem. I don't know. I mean,
Progress.
Other than PHP 6 that you could.
well, no, that was a worthwhile experiment, I think. We learned a lot from it, but I don't know, the biggest problem PHP has is its popularity, in essence, right? There are so many people that have written so much code, a lot of it bad in PHP. And this is both good and bad. One of the points of PHP was to make this stuff accessible to everyone, right? You shouldn't have to have a computer science degree in order to build a website. And PHP kind of did that. It's the visual basic of the web, in a sense, for a lot of people. They look at primitive things like, man, Java is too bloody hard, I have to read all the documentation. They look at something like iTunes WebSphere. Regular people can't figure out what the hell to do, where to even start, right? With PHP, you take your HTML, you've done save as from Word, perhaps, and this ugly HTML. You stuff one PHP tag in there, you copy out of the documentation that says we'll show the date. Magic, it works. Right? You upload it to your ISP, magic, it still works. It runs on your Windows machine, it runs on your ISP, it runs everywhere, and the first little thing you try just works. Right? That's what gets a lot of people hooked on PHP. It's accessible, and it just works. And PHP runs shitty code really, really well. Which is kind of the bane of its existence in the sense that shitty code just runs. You might turn on error warnings and you see thousands of warnings, but damn, this thing still runs. It's pretty damn fast. It's fast enough. It doesn't matter how bad the code is that we write. So in that sense, it gets a really bad reputation with a lot of people because people come along and have to rewrite other people's PHP code. They look at it going, what the hell is this? Right? But that person who wrote it also, this guy's getting paid to rewrite it because this business was a success. I mean, it got to the point where he could hire someone to fix his code. Great. He got started. You should see Zuckerberg's initial code. Terrible. Absolutely terrible. Right? But that's part of what PHP is. It lets you put your ideas online. And in that sense, I don't regret any of those things. Registered globals, great. Because it was really, really easy to explain to somebody who didn't know anything. That make a form, first name, last name, age. Submit. You're going to get first name, last name, age in that destination script. Echo first name, echo age. If age is greater than 21, do something. Really, really easy to grasp for any reason. Right? Without actually going to code, you would have that. You have to go and pull that from someplace. Right? Pull this from get, pull, post, whatever. What's get? What's post? I have no idea what that stuff is. Right? So there are very few things I regret over time. There could be more consistency in some of the different extensions, but it was more about, damn it, we want workload support, we want it now. I don't really care what the API looks like. We can't wait around a year to build a consistent database layer. Let's just get workload support in there because we have 10 people streaming to Oracle right now. Right? It's written by different people, so it looks like different choices. So
How much short open tags? How do you feel about that?
short open tags is great. I still use my short open tags, damn it. And back when I put them in, there was no problem because nobody was using them, right? I read the HTML spec. It said, bracket question mark is a PI tag, process instruction tag. Great, I'm processing instructions in an HTML document. That's what I do. Fast forward a few years, and the XML guys come along and say, wait a second, you can't do that. We want to use that tag too. Screw you guys, I was here first. But they said, no, if you read the spec again, it says you're supposed to name your instruction. So it should be bracket question mark and name the instruction. I was like, okay, fine. I added a longer one. And yes, I could have read the spec, but it was so nice having it next to you. All right, I think I'm out of time. Thank you very much, guys.